Hi, everybody. Let's talk about valence electrons and what they are and how you can find them more quickly on a periodic chart so that you don't have to write out your Bohr model and draw it all out every time just to figure out how many valence electrons something has. The directives that you'll find here on the sheet where it says how to determine how many valence electrons are in any element should be enough to help you figure this out, but I'll go over it with you quickly. The valence shell of an atom is the outer shell. So we've looked at those quite a bit. That outer shell, that very outer one, this would be the valence on the atom, and then this second one would be the valence on its ion. So let's go back to our directions. Where did they go? Here they are. All right. One way to determine how many valence electrons there is, clearly, is to draw that Bohr model every time and just count them, but that can be kind of time consuming. So what we want to do instead is notice that there's a pattern on the periodic chart that helps with that. So group 1, everything in group 1 has 1 valence electron, and group 2, everything in group 2 has 2 valence electrons. When we look at this smaller section down here, that lower level here, all the way from group 3 to group 12, we can understand that those are called transitional metals. And they're called transitional metals because their electrons are always switching back and forth between their outer level, back and forth between a lower one. And so the amount of valence electrons that they actually have varies. And so if I ever asked you one, find the valence in chromium or iron or cobalt, any of these ones that are in this section, you would just say that the number varies. So it's a variable number, and sometimes it's 1, sometimes it's 2, sometimes it's 7. So you wouldn't be able to give me an exact number. It's variable, so it varies. Not specific. Sorry. So now we want to look at the rest of the chart. We've got 13 through 18. And the way that you figure that out, just like it says in the directions, is subtract 10. So everything in group 13 minus 10 would have 3. So it has 3 valence electrons. 14 minus 10 is 4. So that pattern continues. 3, 4, 5, 6, 7. And then everything in group 18 has 8 valence electrons. And there's only one exception to that rule. Helium is the exception to the rule. It only has 2 electrons to begin with. So there's no way it could even have 8. Helium just looks like that very first orbital filled in with 2 electrons. It has 2 valence electrons, but everything else in group 18 has 8 valence electrons. So hopefully you can work with that pattern a few times and understand how to quickly find the valence electrons without drawing the Bohr model. Good luck. Ask for extra support if you need it.